Hello everyone, I am Koji Momota from the Integrated Media Environment Laboratory at Osaka University. Today I will present our work Hybrid Sphere Enhancing Hybrid Meetings with Avatar-based VR Environments. Let me start with the core idea of this work. Hybrid Sphere reconstructs a shared virtual meeting space for remote participants only. Using a single 360-degree camera and real-time pose estimation, local participants are represented as avatars, so a remote HMD user can join a space where everyone appears co-present. I will briefly cover the motivation, system design, and user study results compared with a modified 360-degree video baseline. Hybrid meeting often creates asymmetry between co-located and remote participants. Co-located participants can exchange subtle nonverbal cues more naturally, so remote participants may have lower contextual awareness and involvement. Our objective is to reduce this asymmetry while preserving natural face-to-face interaction for local participants. Existing approaches show a trade-off between contextual richness and deployment feasibility. Layout-based video improves visual equity, but it does not fully restore embodied interaction. 360-degree live video provides realistic context, but it usually remains 3D, so remote users cannot move translationally. Fully virtual platforms are immersive, but requiring HMDs for everyone is impractical. So we target a balanced solution, minimal burden for local participants while giving remote users more spatial flexibility than 3D video. We aim to improve the remote participant experience without increasingly demands on local participants. To evaluate this, we formulated three hypotheses covering avatar effects, navigation effects, and engagement preference. These hypotheses correspond to our two core components, avatarization and Control 6DF navigation. Hybrid Sphere has two parts, a local side capture module and a remote side VR module. On the local side, a single 360-degree camera and pose estimation capture upper body motion and map it to pre-generated avatars, while local participants interact face-to-face without extra devices. On the remote side, the user enters the shared VR space with an HMD, and navigation is implemented as seat-based teleportation, providing limited 6DoF instead of free roaming. We conducted a within-subject user study examining the impact of avatar-based representation on remote meeting experience and task performance. We recruited 16 groups, 48 participants total, with 2 local and 1 remote participant per group. The remote participants experienced both conditions, a baseline with a modified 360-degree video and 3D and the proposed condition with avatarized locals and seat-based viewpoint changes. Condition order was counterbalanced, and most participants are on VR novices. We used two tasks separate avatars effect from navigation effect. Task 1 was brainstorming discussion with seat changes disabled, mainly for H1. Task 2 was a collaborative spatial reasoning quiz with seat-based viewpoint changes enabled, mainly for H2. Both tasks also contributed to H3. We combined subject scales and objective performance metrics. For H1, we evaluated social presence and partner impressions. For H2, we evaluated spatial presence and task performance. For H3, we evaluated engagement and user preferences. We also checked similar sickness. In the discussion task, the baseline live video condition scored higher significantly on social presence and pattern impressions. However, objective outcomes showed no significant differences, and speaking ratio and idea generation were comparable. So avatar representation reduced perceived social richness but did not affect measurable task output. In the spatial task, the baseline condition again scored higher on social presence measures and trustworthiness. We found no significant overall difference in spatial presence or task performance, although VR experiments participants showed a positive trend and hybrid speed. Importantly, enjoyment significantly favored the proposed method, suggesting that viewpoint exploration was engaging even without performance gains. For H1, avatar-based representation did not match live video in social presence and pattern impressions. A likely reason is limited real-time reproduction of subtle facial expressions, gaze, and micro-gestures. Photorealistic avatars with imperfect behavior may also cause an uncanny valley effect. This suggests improving expressive fidelity or using intentionally abstract representations. For H2, we expected viewpoint flexibility to improve spatial presence and task performance, but no significant overall differences were observed. VR experience participants tend to report higher spatial presence, suggesting that familiar with VR interaction affects the effective use of 6DoF navigation. Overall, the benefits of 6DoF appear to depend on user familiarity and task characteristics. For H3, engagement remained stable across conditions. Preference was task-dependent. Live video was preferred for discussion tasks, whereas the proposed method was preferred for spatial tasks. This suggests that interaction modality in hybrid meetings should be aligned with task characteristics. Key limitation includes limited avatar expressiveness, task-dependent 6DoF benefits, and VR onboarding challenges. Our sample was demographically narrow and we mainly evaluated the remote side experience. Future work includes improving avatar expressiveness, beta task-aligned 6DoF use, beta onboarding, and strong support for local awareness of remote presence. In conclusion, Hybrid Sphere is lightweight avatar-based hybrid meeting system using a single 360-degree camera and pose estimation. Avatar representation currently reduces perceived social richness, while 6DoF navigation provides task-dependent benefits. These results highlight both the potential and limitation of VR-based hybrid meeting design. Future work will improve avatar fidelity and task-aligned interaction. Thank you.